Here are some notes on inspiratory valve incompetence. This is relevant to anesthetic circuits or ICU ventilator circuits. The normal function of the inspiratory valve is as follows. The inspiratory valve should open during inspiration of fresh gas flow. In these diagrams down here, the proper flow of gas is always in the counterclockwise direction. So during inspiration, this green arrow flow should be counterclockwise going in this direction. So your inspiratory valve, which will be around here, should be open during inspiration. And your inspiratory valve should close during exhalation. So again, exhalation, you want that flow to continue going in the counterclockwise direction. So your inspiratory valve, which will be down here, should be closed during exhalation. It works with the expiratory valve. The expiratory valve would be on this side of the circuit to prevent rebreathing. There are some signs of malfunction. You have a normal capnography graph shown here. If you had inspiratory valve incompetence, you would have an elevated inspired CO2 baseline. So your baseline here would continuously go up a little bit. That's because if your inspiratory valve doesn't work, when you exhale, some of the gas will go back this way and you'll be rebreathing some of that carbon dioxide. So now your baseline CO2 level will be a little higher. You'll have a prolonged expiratory plateau. This is your expiratory plateau here, and it'll be longer than usual, and you'll have a gradual rather than a sharp inspiratory downstroke. This inspiratory downstroke is the black line here, and it would be more gradual going downwards instead of that sharp arrow or that sharp angle here. There are also some spirometry findings. If you have exhaled gas entering the expiratory limb, your measured exhaled tidal volume would be lower than expected. The management of inspiratory valve incompetence begins with increasing your fresh gas flow. If you have fresh gas flow going counterclockwise in the circuit, you want to increase that in order to prevent much of your expired gas from going in the wrong direction. If you have a faster gas flow going in the counterclockwise direction here, less of that gas will go in the wrong direction. So that's the first thing you should do. The second step is to replace the faulty valve as soon as you can. There are some less effective interventions. You can try increasing your scavenging suction. You can try replacing your gases with oxygen alone to prevent hypoxia, although this would not prevent hypercapnia. You can increase your minute ventilation. This again would not address your fresh gas flow, but if you increase your minute ventilation, you might be able to breathe off some of that carbon dioxide that you're rebreathing, but these are really less effective, and your first thing that you should do is really increase your fresh gas flow. Again, key point, quick recognition and increased fresh gas flow are crucial initial steps, and you always need to replace the valve for the definitive fix.